Hey everyone, welcome to Tutoring. Hope you're having a great day. Today we'll be going through chapter 8b, question 3. So this is your application of integration chapter and we'll be finding areas between two curves. So let's get into the question. Question 3. Find the area of A, region A, so this region right here, and then part B, find the area of region B, so this yellow area right here. So region B is the one that I want to focus on, but we'll go through part A first just quickly and then we'll move on to part B. So how would you find the area between two curves? As you know from this chapter, if you want to find the area between two curves, it's always top minus bottom, right? So it's the general formula is area between two curves. You have your upper terminal and your lower terminal, and then it's the top function minus the bottom function. That's generally always the case. Right, so now the goal is, what is my upper terminal, what is my lower terminal, and then what's my top curve and what's my bottom curve. You need to be able to identify all these 4 points first before you find the area. So how would you find B and A? Well, that's just your intersection point right here between your two curves. That's the lower terminal, that's A, and all the way to -half, right? So that's given to you. So if you want to find the intersection point between the two curves, you make the two curves equal to each other. So that's 1 of x squared equals to x squared. And then now we solve x squared, we bring the x squared over, that's x to the power 4, and that's equals to 1. And of course, you get rid of 4, you 4 root, I hope that's a word, you 4 roots of 1 and you get plus minus 1. So don't forget the plus minus whenever you square root, fourth root, or even root something, okay? So those are your two intersection points. You got -1, and clearly this one obviously has to be a 1. Okay, so now that you've found your intersection point, you can start finding the area. So that is, write out your integrand again. So area is equals to the antidiff upper terminal is -half, because -half is bigger than -1, so -half goes on top and -1 goes to the bottom. Now let's identify what our top curve and what our bottom curve is. If you look at your graph, so this section right here, the graph that is on top or visibly on top is the blue curve right here, which is your 1 on x squared. So that's your truncus. So that is your top curve. You put that first and then it's minus the bottom curve. The bottom curve is your parabola, so x squared. And that's it, guys. You anti-diff this and you should be able to get region A. So I'll just do it quickly here. Make sure whenever you anti-diff your 1 on x squared, you write it in your indices form, so x to the power of -2, and then there we go, we can proceed from there. So let's have a go. Antidiff of x to the power of -2, add the power by 1, bring it down, so that gives us -x to the power of -1, and then -x squared becomes -1 on 3 x cubed. Put it in your box, and then now let's do some substitution. Okay, preferably when you do your substitution, you bring it back to your fraction, just so that you can see where you need to substitute in to avoid the silly mistakes, okay? Right, and let's have a go. So, -1 over x, we sub in -half. Of course, -1 over -half, that gives us a +2. And then we sub in -half into x cubed. That gives us -1 on 8. -1 on 8 times -1 on 3, that is a +1 on 24. And then you sub in the -1, but before you sub in -1, you put in minus, and then you open the bracket just to avoid the silly mistakes, okay? Now let's sub in -1. -1 over -1, that is a +1. Sub in -1 here again. -1 cubed is -1. -1 times -1 on 3, and that is a +1 on 3. Okay, now 2 plus 1 on 24, that is, well, 2 can be written as 48 on 24, so you make them have the same common denominator. 48 plus 1 is 49, and that is over 24, minus 1 plus 1 on 3, that is 4 on 3, and then we make them have the same common denominator of 24, and 49 minus. Okay, so to get 3 to 24, you multiply by 8, you do the same thing on your numerator, and there we go. Our final answer would be 17 on 24, and then because it's area, you put units square. And that's it, guys. That is for region A. Now, region B, I'll do on the left-hand side over here. So for region B, we need to find this yellow area, right? It is also kind of between two curves, because if you think about it, there is the red area. I mean, there's the red curve, and then there's the blue curve, and this area is underneath both of them, right? But okay, I'll rub this side out a little bit so you can clearly see what I want to do here. But if you look at these two curves here, there is no clear top or bottom. Like you can't just say, oh, the red is above the blue for this region. Whereas in region A, the blue is clearly above the red. For region B, there is no top, there is no bottom. So you can't always think of it in that form, top minus bottom. What you can do is, our intersection point here is 1. If you were to split this apart, so right here, right in the middle, right here, so 0 to 1 and then 1 to 2, you will see that you can actually find the area independently. So you can go 0 to 1, area underneath the red curve, and then you can go 1 to 2, area underneath the blue curve. And of course, if you want to find area of region B, I'll write it in red actually for you to see. So that is 1 to 0, so it's 1 to 0, area underneath the red curve, which is your parabola. So you get that area, and then you plus from 2 to 1, so this area right here, this blue area, which is still part of your area, 2 to 1, and then it's now underneath your 1 over x squared curve. So that is your truncus, and then there we go. Just add them together and you'll be able to get the region B's area, okay? So let's have a go. X squared, well, that just becomes 1 on 3 x cubed, and then sub in 1, 0. And for the blue one, we know that when we antidiff 1 on x squared, which is x to the power negative 2, we get negative 1 on x. So I'm just going to rewrite that again. Negative 1 on x, we sub in this time 2 and 1. Okay, so the red area, so the one over here, the area underneath the red curve, the parabola, would give us 1 on 3. When we sub in 1, you sub in 0, you get 0. That's why 0 is such a good number. And we sub in the blue part as well. So sub in 2, we get negative a half, and then you sub in 1, it's make sure when you sub in 1 you put a minus, and it's a minus of a minus, so that gives us a positive 1. Okay, and then 1 on 3 plus, so 1 on 3, and then that's plus a half, and our final answer should be 5 on 6, and then units square. Okay, so that's pretty much it for region B. Shorter than region A actually, but it takes a bit more thinking. You have to think a little bit outside the box, and as opposed to top minus bottom all the time, okay? So that's what I want to leave you guys with today for chapter 8b, question 3. Hopefully you found this video useful, and if you did, please leave a like on the video. And aside from that guys, thanks for watching, and I'll see you in the next video.